So we are computing mode in discrete series, and this is the grouping method. In case of grouping method, we prepare 6 columns. Grouping table, we prepare 6 columns. The first column represents frequency itself. The second column represents sum of two frequencies. So we have done 2 plus 3, 6 plus 12, 28 plus 24 and so on. In the third column, we have sum of two frequencies ignoring first. So we left the first item and we have added the sum of two frequencies. Now fourth column is sum of three frequencies from the starting one. So three frequencies, this is the 3 frequency. 639 plus 2, it's 11. Then 12 plus 20 plus 24, this is 56. Then 25 plus 7, 32 plus 5, 37. Now in the last we just have 2 items, so we ignored them. So fourth column is sum of three frequencies. Now we move to fifth column, and fifth column is sum of three frequencies ignoring first. So we ignore first and we take the sum of next 3 frequencies. So this is 639, 12, 21. Then we have 20 plus 24 plus 25. This is 69. Then we have 7 plus 5 plus 3. This is 15. And last we have just one item, so we ignore it. So first column is frequency itself. Second column is sum of two frequencies. Third column is sum of two frequencies ignoring first. Fourth column is sum of three frequencies. Fifth column is sum of three frequencies ignoring first. And sixth column is sum of three frequencies ignoring first 2. So we ignore first, second. So we'll take the sum of next 3. So this is 32 plus 6, 38. Then we have 24 plus 25, 49. And then 7, 56. Then we have 5 plus 3 plus 1. This is 9. So this is our grouping table. So we have created grouping table. Now we move to analysis table. Analysis table. So in case of analysis table, what we'll do, we again list out the marks. So marks is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Now we list out the highest item in column 1. So suppose in column 1, as we just observe, the highest value in column number 1 is 25, which is of 13. So we mark a tick in column 1 in front of 13. Now we move to second column. In second column, the maximum frequency is 44. And how we compute 44? This is the sum of 11th and 12th item. Yani ke 11 plus 12. This is the sum of 11 marks and 12 marks. So what we'll do in the second column, we put a tick on 11 item and 12 item. Now we'll move to third column. In third column, the maximum frequency is 49. Again, this is a sum of, you can say red one, this is a sum of 24 and 25 frequency, which is basically the frequency of 12 and 13. So what we'll do in third column, we put a tick on 12 as well as 13. Now we'll move to fourth item. The highest frequency in case of fourth item is 56, which we have computed by adding the frequency of 10, 11 and 12. So we put a mark in fourth column in front of 10, 11 and 12. Now we move to fifth column. In fifth column, the maximum frequency is 69, which is sum of frequency of 11, 12 and 13. So we put a tick in front of 11, 12 and 13 in fifth column. Now we move to last column, sixth column. The highest frequency in sixth column is 56, and which is a sum of 24, 25, 7, which is basically the frequency of 12, 13 and 14. So we simply put a tick in front of 12, 13 and 14. This is an analysis table. So now we have to count the number of ticks against every item. So this is 1, this is 3, this is 5, this is 4 and this is 1. The item which has maximum ticks, that is our mode. So in this case our mode is 12. By observation we will get that the mode is 13, but when we applied grouping method then we came to know that our mode is 12. So make sure, remember one thing when you have to apply grouping table. When the item whose frequency is maximum, the frequency of its preceding item or succeeding item is very competitive, there is a minute difference between the frequencies, then you have to apply grouping table. In grouping table, we have two tables. One is grouping table, second is analysis table. In grouping table, we compute 6 columns. First column is frequency itself. Second column is sum of two frequencies. Third column is sum of two frequencies ignoring first item. Fourth column is sum of three frequencies. Fifth column is sum of three frequencies ignoring first item. And sixth column is sum of three frequencies ignoring first two. Then you have to prepare analysis table. You have to mark ticks against the item which is maximum in each column. Like you have to identify in column number 1 whose frequency is maximum, tick that item. In column number 2, which two items the sum of whose frequencies is maximum, tick those items. Similarly in third, tick those items, two items whose sum of frequency is maximum. In case of fourth column, sum of three items whose frequency is maximum, tick those items. Similarly in fifth and sixth. So item who has having maximum number of ticks, that is your mode. So you can apply inspection as well as grouping. So inspection when there is not a huge difference. When there is a huge difference between the frequencies, then apply inspection method. And when there is a minute difference between the frequencies of succeeding or preceding class, then you have to apply grouping method. So this is the discrete series. Now let's move to continuous series. Now this is the continuous series in which we have been given class interval as well as the frequency. Now how we will compute mode? Again we have two methods, inspection, grouping. So situation to situation you have to decide कि you have to identify grouping method or inspection method. So in this case the maximum frequency is 30 and the preceding class and the succeeding class, the frequency of these two classes is not competitive. There is a difference between that. So we apply inspection method. So by inspection method, we came to know that the item having maximum frequency is 30 are classes. Now in this case, we won't get the item because this is not a discrete series. This is a continuous series. So in this case, we'll get the model class, the class which is having maximum frequency. So the model class is 15 to 20. So first thing, we'll identify model class. Now second thing is we have to find out mode. So formula for mode is L1 plus F1 minus F0 upon 2F1 minus F0 minus F2 into I. Now what this formula means, let's explain. Now L1 is lower limit of model class. L1 is lower limit of model class. So as in this question, our model class is 15 to 20. So lower limit of model class is 15. So we write down 15 in place of L1. Now what is this F1? This is frequency of model class. The class in which mode lies, the frequency of model class. So now our model class is 15 to 20. So the frequency of model class is F1. So we write down 30 in this case. Now what is this F0? This is frequency of previous class. Previous class, that of model class. So if our model class is 15 to 20, so the previous class is 10 to 15. So the frequency of 10 to 15 is F0. So we write down here 15. Now F1 we know this is 2 into 30. F0 we know this is the frequency of preceding class, that is 15. Now what is this F2? This is frequency of succeeding class, the next class. Frequency of succeeding class. So the succeeding class of model class is 20 to 25 and the frequency of 20 to 25 is F2. So that becomes 20. So our F2 is 20 into I is class interval of model class. The class in which mode lies, that class is called model class, and you have to take the difference of the lower limit and upper limit of model class. So the difference is 5. So we write down here 5. Simply solve it, you will get the mode. So 15 plus 15, 60 minus 35, that is 25 into 5. So this is 5 5s are 25, 5 3s are 15. So our mode is 18. So this is the continuous series, and in this case we have applied simply inspection method. So by inspection method, first we identify our model class, and when we came to know about model class, the next thing is we find out the mode, and the formula for mode is L1 lower limit of model class plus F1 minus F0, यानी कि difference between frequency of model class and preceding class, divided by 2f1 minus f0 minus 2, यानी कि difference between the twice the frequency of model class and sum of frequency of preceding class and succeeding class multiplied by interval of the model class. This is how we can compute mode in case of continuous series. Now next thing, now simply just look at this thing. You have to calculate mode of the following series. Now when we just observe the series, we came to know that there are two class intervals which have the same frequency and both have the maximum frequency. So this is called bimodal distribution, because in this case we have two modes of the series. One mode lies in 10 to 15 class and second mode lies in 20 to 25 class. Now most important thing is, in such a scenario we can't calculate the mode as per normal method. Like first we identify the model class, then we apply the formula L1 plus F1 minus F0 upon 2F1 minus, because we get two modes. So to avoid these two modes, we have another method through which we can compute mode. In that case, we use empirical relationship between mean, median and mode. What is the empirical relationship between mean, median and mode? Now this is, we can specify with the help of this equation. Empirical relationship between mean, median and mode, and that is mode is equal to 3 median minus 2 mean. So this is the empirical relationship between mean, median and mode. So whenever you have a bimodal series in which there are two modes, the only method to find out the mode you can find out using this equation. Mode is equal to 3 median minus 2 mean. That means in this scenario, first we have to compute mean, then we have to compute median, we have to put the values of mean and median in this equation, and then we can easily compute the value of mode. Well, let's start. First we compute mean. So I have already told you this is your x and this is your frequency. So for computing mean, we basically use direct method. So according to the direct method, we have to compute fx. So for that, first we have to compute mid value. So first we'll compute mid value and then you apply direct method to solve the question. So mid value is lower limit plus upper limit divided by 2. So this is 2.5, 7.5, 12.5, 17.5, 22.5, 27.5 and 32.5. This is a mid value. So we have to multiply frequency with the mid value. So what it becomes? This becomes 2.5, this becomes 15, this becomes 125, this becomes 70, then 225. Now this becomes 9 5s are 45, 9 7s are 63, 67, 247.5 and then we have 65. Now we have to add all these values. So by adding this we got 3, 5, 8, 5, 13, 5, 18, 7, 25, 30, 4, 6, 13, 15, 19, 25, 2 to 4, 5, 2 to 4, 6, 7 होगा 5 to 7, 9, 11, 8, 11, 4, 15, 6, 21. I have made some mistake. 5 and 5, 10. 2, 3, 5, 18, 5, 23. 2, 3, 5, 8, 5, 13, 5, 18, 25, 30. 3, 4, 6, 13, 15, 19, 6, 25. 4, 6, 7. So this becomes 750. And sum of frequency is 10, 20, 24, 26, 27, 9, 36, 38. So mean is 750 divided by 38. So if we calculate it with the help of calculator, so we have 750 divided by 38. So this is equal to 19.74. Our mean is 19.74. So first we have computed arithmetic mean. Second thing, we compute median. So median, as you know, this is a positional average. So first we have already in ascending order, then we compute CF, cumulative frequency, 1, 3, 13, 17, 27, 36 and 38. So first we'll compute rank. Rank of median is n by 2, 38 by 2, that is equal to 19. 19 lies in 27, that means our median class is 20 to 25. That we have already discussed in the last class how to find out median. So median class is 20 to 25. Now formula for median is, that is L1 plus rank minus cumulative frequency of previous class divided by frequency of median class into class interval of median class. So lower limit of median class is 20, rank is 19 minus cumulative frequency of previous class is 17, frequency of your median class is 10 and class interval is 5. So this becomes 19 minus 17, 2 by 2, we have got median 21. Now simply put this value into the equation. Median is 21 and mean is 19.74. So this is 63 minus, there is a huge difference, 3 this, so our mode is 9 minus 4 5, 12 minus 9 3, 5 minus 3 2. So our mode is 23.52. So make sure this scenario applies only those situations where we have bimodal series. It means series has more than one mode. In that case, we use empirical relationship between mean, median and mode. That is, mode is equal to 3 median minus 2 mean. So first you have to compute mean, then median, then put the values of mean and median in this equation. You can easily get the value of mode. Now next question, that is the question of missing frequency. So find the missing frequency when median is 25 and mode is 24. So now in this case, the median given is 25 and mode is 24. We have already discussed few questions of missing frequency in case of median and quartile deciles. So whenever there is a case of missing frequency, then in that case you can't calculate the median class from the cumulative frequency. You can simply calculate the median class with the help of value of median given in the question. So let's start. First we compute cumulative frequency. So what we have done, we have assumed the missing frequency as x and y. So we have 14 plus x, then 41 plus x, we have 41 plus x plus y, and then we have 56 plus x plus y. Now the total frequency is 56 plus x plus y. So rank of median is n by 2. So now in this case we haven't given n, so we take the sum of frequency 56 plus x plus y upon 2 as rank. So from this value we cannot judge in which class our median lies, but we have given the value of median, that is 25. So from this value we can easily judge that our median class is 22 to 30. 20 to 30. So now simply write down the formula of median. So median is equal to L1 plus rank minus CF upon F into I. So our median class is 20 to 30. So lower limit is 20. Rank we have computed, this is 56 plus x plus y upon 2. Cumulative frequency of previous class. So our median class is 20 to 30. So previous class is 10 to 20. So the CF of previous class is 14 plus x upon frequency of median class is 27 and class interval is 10. And our median value is 25. Now solve this equation. We will get a first equation. 25 minus 25 upon 10, that is equal to 56 plus x plus y. We have taken 2 as LCM, minus 28 minus 2x upon 27. So 5 2s are 10. So this 2 is cancelled with this 2. So we have x minus 2x, this is minus x plus y plus 28 equals to 27. So this is minus x plus y equals to minus 1, or we can write it down x minus y equals to 1. This is my first equation. I have multiplied the both sides with minus 1. So my equation becomes x minus y equals to 1. This is my first equation, which I have computed from median. Now second thing is, we have been given mode. So if we just look at the value of mode 24, we came to know that the model class is 20 to 30. So our model class is 20 to 30. So in that case, this 27 is F1. The item before that, that is, so its frequency is F0, and the next item's frequency is F2. So simply write down the formula of mode. Mode is equal to L1 plus F1 minus F0 upon 2F1 minus F0 minus F2 into I. So simply put the values. Mode is 25, lower limit is 20 plus frequency F1 is 27 minus x upon 2 into 27 54 minus x minus y into 10. So 25 minus 25, and this 10 come in denominator. So this is 27 minus x upon 54 minus x minus y. Simplify it. Cross multiply. 54 minus x minus y, that is equal to 54 minus 2x. So this is the equation, 27 minus x and 54. 2 sevens are bilkul. So 25 upon 2. So this becomes 54, 54 cancel. So this is x minus y equals to 0. So if we solve both the equation using elimination method, x minus y equals to 0. There is some mistake in this question. 54 minus x, 2x, 54 minus x minus y. So this becomes minus 2x इधर आ गया, x minus y equals to 0 और यहाँ पे आ रहा है x minus y equals to 1. How this is possible? Just a second. 25 equals to 20 plus 56 plus x plus y upon 2 minus 14 plus x. ठीक है, upon 27. So this becomes 25 minus 25 upon 10, 56 plus x plus y minus 28 minus 2x upon 2 into 27. 2 cancel. So this becomes 56 plus 56 minus 28. So definitely it's 28. So minus 2x plus x minus x plus y plus 28 equals to 27. So minus x plus y equals to minus 1. So x minus y equals to 1. So I hope there is some mistake in the question. So this is L1 plus F1 minus F0 upon 2F1 minus F0 minus F2. So 2F1 is 54 minus x minus y, 27 minus x. So this becomes 25 minus 25 upon 10, 2. So 54 minus x minus y is equal to 2 7 are 14, 2 2 are 5 minus 2x. So 54 cancelled with each other. So we got minus x, 2x यहाँ गया तो 2x minus x minus y equals to 0. So if I say x minus y equals to 1 minus plus, तो ये तो सब आपस में cancel हो जाएंगे. There is some mistake in this question. Maybe there is some writing mistake. So whenever you get two equations, simplify the equations using elimination method and you will get your answer of x and y. So maybe there is some mistake in the figure or anything due to which we are not able to solve the answer, but when you solve it you will easily get the answer. So by this you can get the value of x and y. Next question. The median and mode of falling wage distribution of 230 workers. Now there are 230 workers and you have been given median and mode. So in this case, now this is the scenario when there are 3 items are missing. We have 3 missing items. So when we have 3 missing items, how we can solve the question? Just have a look how we can solve the question. So in this case, this 230 is sum of total frequency. And this is your median. And this is your mode. So now we have to find out the missing frequency. So first thing I have done, I have named the missing frequency as XYZ. Because as we have been given median, to calculate median we need cumulative frequency. So cumulative frequency is 4, 20, 20 plus x, 20 plus x plus y, 20 plus x plus y plus z. Then we have 26 plus x plus y plus z, and then we have 30 plus x plus y plus z. So whenever we have two frequencies are missing, we have been given 2 parameters as in the last question. Now in this case there are 3 frequencies are missing. So we have been given 3 parameters. The first parameter is total, second is median and mode. So first equation we got 30 plus x plus y plus z, that is 230. So the value of x plus y plus z, that is equal to 200. This is my first equation. Now second equation we get from median. As we look into the value of median, we came to know that our median class is, because it's 33.5, so median class is 3240. So let's put the value of median and other things in the formula of median. L1 plus rank. Rank is n by 2 minus CF upon F into I. So median given is 33.5. Lower limit is 30, n by 2. Now in this case we have been given total frequency 230. So we don't need to put 30 plus x plus y plus z. This will complicate our question. We simply say 230 upon 2 minus CF of previous class. So our median class is 30 to 40. So CF of previous class is 20 plus x. Now frequency of the median class is 30 to 40, it's y, into class interval 10. So 33.5 minus 30, this is 3.5 divided by 10. That is 115 minus 20 minus x upon y. So we came to know that this is 35 upon 100. So this is 35 by 100 is equal to 95 minus x upon y. So simply 7 upon 20. So this is 7y equals to 1900 minus 20x. So our first equation is 20x plus 7y equals to 1900. This is our second equation which we have computed through the formula of median. Now the third parameter is mode, and when we look to the value of mode, our model class is 30 to 40. Again, so the formula for mode is L1 plus F1 minus F0 upon 2F1 minus F0 minus F2 into I. So mode is 34, lower limit of model class is 30. Now F1 is frequency of model class, F0 is frequency of previous class, and F2 is frequency of succeeding class. So this is 30 plus y minus x upon 2y minus x minus z into 10. So this becomes 34 minus 34 upon 10, that is y minus x upon 2y minus x minus z. So this is 2, this is 5. So by cross multiplying we got 5y minus 5x equals to 4y minus 2x minus 2z. So this becomes 5y minus 4y, y, 2z positive, and minus 5x plus 2x. So this is minus 3x plus y plus 2z equals to 0. Now first thing what we'll do, by using first and third equation, we first convert it into 3 variable equation into 2 variable equation. We have to remove z. So what we have done, we have multiplied this equation by 2. So the equation is minus 3x plus y plus 2z equals to 0. Now second is 2x plus 2y plus 2z equals to 400. Minus minus minus, this is removed, minus 5x minus y equals to minus 400. So our equation is 5x plus y equals to 400. Now second equation is 20x plus 7y. So multiply this equation by 4. So this is 20x plus 4y equals to 1600. And this is 20x plus 7y equals to 1900. Subtracting both the value equations, This becomes minus 3y equals to minus 300. So y is equal to 100. We got our first frequency. If y is 100, then x is, by equating into this, y is 100, 20x plus 7y equals to 1900. So 2x is equal to 1200. X is equal to 20x is equal to 1200, so x is equal to 60. So we got y equals to 100, x equals to 60, and we easily know that x plus y plus z is equal to 200. That means the missing value is 40. So this way we can fill the missing frequency. Now let's move to the properties of mode. Again, a very important question. You have discussed this property in median, mean as well. So all the measures of central tendency, mean, arithmetic mean, median and mode satisfy this property. And what this property means, mode is dependent on change of scale. Dependent on change of scale and dependent on change of origin. I have already explained you the meaning of change of origin and change of scale. Now suppose I have been given x. X is 10, 9, 9, 10, 10, 7, 10, 9. Suppose this is my x. Now if I just observe it, my model value is 10 because 10 is repeating 4 times. So my mode is 10. Now change of origin means addition or subtraction of a constant. Now if I say x plus 5, I have added a constant 5 in all the items of the series. This becomes 15, 14, 14, 15, 15, 12, 15, 14. Now the mode of the revised series is 15. That means mode is also increased by the item which we have added in the entire series. So mode becomes 15. If I subtract any number, say suppose I subtracted 2 from all the items of the series, this becomes 8, 7, 7, 8, 8, 5, 8, 7. Now in this case my mode becomes 8. So mode is subtracted by 2. If I multiply the entire series by 2, so that becomes 20, 18, 18, 20, 20, 14, 20, 18. In that case, my mode becomes 20. So that is multiplied by 2. So this 2 is called change of origin and this is called change of scale. So mode is dependent on change of origin and dependent on change of scale, means if we add any constant or subtract any constant, multiply or divide, then mode also changed by the same amount. Now suppose you have been given y equals to a plus bx. Now here a is origin and b is scale. And you want to calculate the mode of y series. So simply what you have to do, a is a constant, write down in the same way, b is again a constant, replace x with the mode of x series and you will get your revised mode. Now in this case x plus 5, so that means x mode plus 5. So our original mode is 10. So this becomes 10 plus 5, 15. If I say x minus 2, so mode minus 2, 10 minus 2, 8. This is x multiplied by 2, mode multiplied by 2. That becomes 20. This is called dependency on change of origin and dependency of change of scale. Next, merits and demerits. Now mode is basically the frequency, depends upon the frequency of the item. So of course it has a very limited application. So mode, the merits, it's not rich, it is easy to calculate and simple to understand. Mode is not affected by extreme items because mode is generally based on frequency, and whenever we say mode never exists in range items, it always exists in middle items. So mode is not affected by extreme items. So mode is simple to understand, easy to calculate, not affected by extreme items. Now next thing is mode is not affected by sampling fluctuation, because mode is the value which is most frequent. So whenever you will take sample randomly, then maximum times the item which is having which is repeating again and again, so you pick up those items. So generally in that case it is not affected by sampling fluctuation. Means if we take multiple samples of a population, then mode of each sample is approximate to each other. Then mode can be calculated in case of quantitative data as well as qualitative data. We can compute mode of numerical data as well as qualitative, means data related to attributes. We can compute the mode of both the series. Mode can be calculated in case of open-end series. Now open-end series is those series in which the lower limit of first class is missing or the upper limit of first class last class is missing. So that is called open-end series. So mode can be easily computed in case of open-end series. Mode can be computed graphically. We can compute mode graphically via histogram. So like this, if we have a series, now this is a histogram. So we can compute the item whose histogram is maximum. Now suppose this is a histogram. So what we'll do, this is the item whose frequency is maximum. We simply join the points with this. Now this intersection, this is called your model value. So we can compute mode graphically with the help of histogram. All these are benefits of mode. Now next is demerits of mode. What are the various demerits of mode? So we can say mode is not rigidly defined. Mode is not rigidly defined. Means we have a series in which more than one mode exists. So rigidly defined means unique value, and it's possible that mode can have a series can have more than one mode. So it is not rigidly defined. Second thing is, it is not based on all the items of the series. Whenever we compute mode, we simply say the item which is repeating again and again. So we simply consider those items which are repeating. We neglect those items which are not repeating. So mode is not based on all the items of the series. Mode is not capable of further algebraic treatment. Like we say, if we want to use mode in further analysis, then mode cannot be used in further analysis. And mode has no mathematical properties. So these are the demerits of mode. So we have the last concept of central tendency, that is relationship between mean, median and mode. Now when we talk about the relationship between mean, median and mode, it depends upon type of distribution. What type of distribution we have, that type decides the relationship between mean, median and mode. Now we have two types of distribution. We have symmetrical distribution. We have symmetrical distribution And second, we have a symmetrical distribution. Now what it means, symmetrical and asymmetrical. Now symmetrical distribution is there when there is an equal distribution. This is called symmetrical distribution, which is a bell-shaped curve in which area on both the sides are equal. Like if we fold it from the mid, then these both ends lie on each other. This is called symmetrical distribution. So in case of symmetrical distribution, at this point where you have maximum frequency, at this point mean is equal to median is equal to mode. So in case of symmetrical distribution, mean, median and mode, all three are equal at this point. This is symmetrical distribution. Now asymmetrical distribution means when there is not equitable distribution, like it can be in this form or it can be in this form. This is called asymmetrical, in which the shape is not bell shaped. So there are two types of asymmetrical distribution. One is positively skewed, and second is negatively skewed. Now first understand what do you mean by positively skewed. Now positively skewed distribution is just like this, in which the tail lies at the right hand. This is called positively skewed distribution. So if you just have a look, you have the maximum peak at this point. This becomes your mode. Median lies in between. This is called median. And mean is average, so mean lies at this point. So in case of positively skewed distribution, mean is always greater than median, greater than mode. So highest value is mean and the lowest value is mode. This is called positively skewed distribution. And when we talk about negatively skewed distribution, so its tail lies at the left end. So it is in this format. This is called negatively skewed distribution. So in case of negatively skewed distribution, here the peak is maximum. This is your mode. So mean or median always lies in between, in the middle. So that is median, and mean is here. So in case of negatively skewed distribution, mean is always less than median, less than mode. So the smallest value is of mean in case of negatively skewed distribution, and in case of positively skewed distribution, the highest value is of mean. So this is very important. You must know what is symmetrical distribution and what is asymmetrical distribution. So in case of symmetrical distribution, when there is an equitable distribution of everything, then mean, median, mode, all three are equal. In case of asymmetrical, we have two types of distribution, positively skewed and negatively skewed. So when we talk about positively skewed distribution, so first we get the mode, then median, then mean. So mean is always greater than median, then greater than mode. And in case of negatively skewed distribution, the mode is maximum. So mode is greater than median is greater than mean. So if anybody asks you which average is appropriate in case of asymmetrical distribution. So if you just look at the asymmetrical distribution positively and negatively, median always lies in between. So if anybody asks you which average is better in case of asymmetrical distribution, so in case of asymmetrical distribution, the most appropriate average is median because it always lies in between. So that's all about the central tendency. So we have discussed all the averages of central tendency. We have discussed mean, median and mode. If you have any doubt, any query, you can please ask. If you have any query, any student is having any doubt, any query, you can please raise your doubt. You can raise your query and I'll sort it out. So please ask your queries. So that means you don't have any question, any queries? Chaliye. So this is our first topic, that is central tendency. Now today we'll start the next topic, that is called